at work energy, so and power. So we are going to look at one of the questions in the total sheet, which says a block of mass 2.5 kg is pushed a distance 2.20 meters along a frictionless horizontal table by a constant applied force. So that magnitude, which is 16 newtons, which is directed at an angle of 25 degrees below the horizontal, as shown in this figure. Determine the work done A by the applied force, the normal force, the force of gravity, and the net work on the table. First of all, we need to write a free diagram. It will be really important not to ignore that. And we can say, imagine, so this is a table, right? Sure. So this is a table. So in this table we have this, okay, block, and the mass of the block, the weight is mg, right? You agree? So that's the mass, that's the weight. Then at the same time, you must be able to agree the mass is 2.5 kg as given in the question. And we have, if this is a table here, right? As the weight is acting down, that means there's a force which is equal to the weight but the opposite in direction, called the normal force. So there is a normal force here. Okay, sorry. Then we know the distance from there to there. It's what? 2.2 meters. And what else? We have a force being directed at that angle. Sorry. So we have a force which is being directed at that angle. So there's a force at that angle there, like that. All right. And that is the angle that you are seeing there. There, 25 degrees. What? So, sorry, 25 degrees. Okay, so we need to find the components of this force which is acting here. So we have the vertical component, okay, in that way, and the horizontal component in that way. So this force here that we are seeing here, we have the force in the y and the force in the x. And we know that for us to find the work done, the distance and the force must be in the same direction or in the opposite direction. In short, they must be parallel to each other. So how do we find work done? Part A. Work done by the what? By the applied force. The work done by the applied force is that we are going to get the horizontal component of this force, then we multiply by the distance. That's all. So now work done, okay, by the applied force will be equal to the force in the x direction, because the distance is in the x direction as well. Even the force must be in the x. So in short, they must be parallel to one another. We are multiplying by the distance. Now take note that the fx is as a component of this force, it's just f cos 25 degrees multiplied by the distance. The force is 16 newtons, so we are saying cos 25 degrees, we're multiplying by 2.20 meters, and this gives us work by the applied force equal to 31.9 joules, and that's how you do it. Alright, now part B says the work done by the normal force which is being exerted by the table. So this is the normal force that I'm talking about. Now you know that the normal force and the distance, they are perpendicular. So it's like this. We have the normal force here. Okay, so this is part B. And the distance is like this. The distance. And these are perpendicular. Now remember what I said. For work to be done, the distance and the force must be parallel to one another. And these are perpendicular. So in short, we are saying work done is just a 0 here. But the normal force will be equal to the normal force itself. Now the angle is 90, right? I want to show you why we are saying 0. The angle is 90 here. So we're going to say cos what? 90 times what? Distance. Now what is cos 90? Cos 90 is 0. So give us what? 0 joules here. That's all. C says the force of gravity. Now the force of gravity is just this one here. Now even the force of gravity itself, it's the same issue. The force of gravity is acting in this way, mg, and the distance is like that, d. They are still perpendicular to one another. In short, just the work done by gravity will be equal to mg cos what? 90 times d. Now cos 90 is 0, so everything here will be what? 0. Then D says the net force on the block. Now the net force is just the total forces like everywhere. So you're talking of the force of gravity, the force of what, the normal force there, and all the components. Now please, let's take it in this way. The question was supposed to be the net work, not force. It's supposed to be the net work. The net work on the block, it will be the addition of all the works that have been done on the block. That is the work done by the force plus the work done by the normal force plus the work done by what? By mg, which will give us the work what? The net work. And the work done by this is what this was, that 0 plus 0, and the net work will be equal to 31.9 joules. Of course, when they talk of net forces, if that what the question was asking about, we'll just talk of the forces in the x-axis and the forces in the y-axis. That's all. Then find those sums, then come up with a magnitude of those forces. All right, so this is how this question was supposed to be answered. I hope you enjoyed this video. Please don't forget to put a subscription there and share.